Hey folks, you're listening to the Java Easily podcast, episode number 3. Java Easy. News, tutorials, tips. Everything you need to know as a beginner Java developer. Hi there, welcome back to the Java Easily podcast. My name is Matt Speak, I'm your host. And just before we get started, if it turns out that you're completely new to Java and you haven't yet grabbed your Java Beginner's Starter Kit, just go over to our website at javaeasily.com and go grab it there. It's a super helpful guide. It's going to get you up and running really quickly with Java. It's completely free and it's just a really good resource for absolute beginners to get started with Java programming. So now in this episode we're going to have a look at another answer which I've had from one of the Facebook group requests, and that's basically a desire to become what the person referred to as full-fledged Java developer. So let's have a dig in now, and I'll just give you my experiences of what it's like to actually be a full-fledged Java developer, which is hopefully useful. So first off, fully-fledged Java developer. So when I hear the term fully-fledged Java developer, I'm like, what does that actually mean? Because there are different ways you can kind of interpret it. So in my experience, you have different types of Java developer, depending upon the actual role that they're going to do, or more specifically, the types of project that they're going to work on in a specific job role. And so I'll just run through what these are now, the ones that I can think of off the top of my head. So the first type of Java developer role you have a core Java developer role. But this is popular in banks and financial institutions. And what a core Java developer role is, it's somebody basically who is only dealing with core Java. So the systems that they're going to be working on, to go back to the idea of banks, for example, banks have a lot of, particularly in trading systems development and low latency, high frequency trading systems, you're going to have components which are just developed in pure Java. So by pure Java, we mean that it's just using the APIs present in the JDK, specifically in the standard edition JDK. So you've got two versions of the JDK. You've got J2SE, which is the standard edition, and you've got J2EE, which is the enterprise edition. That's been rebranded as Java EE from the past probably 7 or 8 years ago, I guess, now. But at any rate, you have these two different versions. So the standard edition and the enterprise edition. Now the standard edition covers all of the stuff that we're used to as Java developers for standard Java programming. So things like, the collection classes in Java util, the ability to do input and output with streams and readers in java.io, the ability to do sockets and networking, that kind of stuff. We've also got stuff in there as well for like date and time manipulation and that kind of thing with dates and calendars and things like that. And so basically in Java terms, that's as like close to the metal as you're going to get. So you can't get any deeper there. You're pretty much building systems out of the kind of lowest level constructs, if you like, which Java gives you, which are present in this J2SE platform that core Java systems are developed on. Well, this is different from Java EE. So the enterprise edition stuff, that's covering extra stuff which enables you to interact with different enterprise systems or systems that you'd find within an enterprise. So when we say enterprise systems, we mean things like messaging systems for sending and receiving messages. So that's through the javax.jms API, for example. So that's through JMS, the Java Messaging Service. We've got JDBC, which is the Java Database Connectivity API, which enables us to interact with databases, so relational database management systems like Oracle, MySQL, Postgres, those kind of things. We've got JTA, which is the Java Transaction API, which is for managing transactions between different components. So for example, you can have distributed transactions where you basically want to consume a message from a queue in a messaging system, but at the same time write an entry to a database. And with a transaction, what you're doing is you're kind of wrapping those up as an atomic operation so that if one of them fails, the state of the world will be rolled back to before that operation happened. So in other words, if you try and read a message off a queue whilst at the same time doing some inserts into a database, if for whatever reason you couldn't do the inserts, then basically the state of the database won't change. It'll be as it was before that transaction. And similarly as well, the message will be put back on the queue and the queue will be in the same state it was before the transaction. So things like that. That's the notion of transactions at least. And you have other APIs as well. JNDI is another one, for example, so Java Naming and Directory Interface. That's basically how you get references to things like queues. So for example, in what we just said, on an application server, typically you'll have connection factories and queues and those kind of things which are registered on the application server, and JNDI gives you a mechanism as a client, in other words a component that wants to access those resources from the application server. It gives you a mechanism of being able to grab them from the application server through a kind of factory mechanism. But anyway, that's getting kind of low level, but the point is you have the standard edition and you have Enterprise Edition, and Core Java is purely focused on Standard Edition stuff. In other words, it doesn't rely on any other kind of third-party libraries or open source libraries that you probably know about, like Spring, the Spring framework, for example, or Spring Boot or Hibernate. You wouldn't see any of those kind of technologies in a Core Java project. You'd mainly just see kind of the lowest level Java, making calls, with the code consisting of just calls to just using objects from the Standard Edition platform. Occasionally, you might get some messaging stuff in there where they're making some kind of JMS type call. That's very rare. In general, it's just pretty much as low level as you can get in those things, where they're usually doing things like very low level custom networking by creating their own sockets, reading from those sockets, that kind of stuff, or using Java NIO, which is a non-blocking API for input and output. And they're usually doing that using all of the concurrency utilities and all the multi-threading kind of stuff, which is part of J2SE. And threads are where you can basically execute things in parallel on the same JVM to make a system that's much more quicker and much more performant. So that's why in general, you'll find that banks writing trading systems, they'll be developing those systems using Core Java because they don't want to have the overhead of invoking a framework like Spring or an ORM framework. That's object relational mapping, where you can map a set of objects, like a domain model if you like, onto a relational database schema. They don't want to have the performance overhead of calling those other systems, and not only the performance overhead as well, but the added complexity of bringing in those frameworks, and also the fact that if things go wrong, then they have to start stepping through code in those frameworks which they don't own. If they have to make changes, then maybe they can't make the changes because it's now in third-party libraries, that kind of stuff. So in general, banks for trading systems and high-frequency trading development, they're going to use Core Java. This also means as well, by the way, that if you want to get the big bucks, then Core Java is definitely a way to go, because then you can start working on things like high-frequency trading systems using those Core Java skills that you've got. Another tip as well as far as that goes, in order to get into those kind of jobs, you really have to know things like algorithms and performance complexity, recursion, kind of really low level, almost like theoretical computer science type stuff, or at least a kind of like advanced stuff that you'd expect to find in a computer science degree relating to algorithmics. You'd really have to know that stuff, well, have a very strong grounding in it at least. So yeah, that's the first type, Core Java developer roles. The other type are kind of back-end web developer roles, I'd say. So I'd kind of split this up into two parts. So when we say back-end, it's like, well, the back-end of what? Well, the back-end of a web application. Particularly at the moment, there's a big drive towards microservices-based architecture. And in a nutshell, what microservices are their individual components which you can deploy as separate units. So they'll run as separate, effectively as separate web servers, if you like, which can give some client the ability to store and retrieve different information relating to whatever domain it's serving. That sounds so abstract now I say that. I'm trying to make it less abstract in my head, but ultimately in a microservices architecture, instead of just having, like, for example, one web server which has the web application running on it, so you have a WAR file, you deploy that to a web application container like Tomcat, for example, and as part of that web application, you're going to have two aspects to it. You're going to have the front-end code and you're going to have the back-end code. So the front-end code is the code that you're going to actually ship out to the browser. So when a user logs into a web application and he or she accesses the first page, then, index.html or whatever, that index.html has been packaged up inside that WAR file. There's normally a source main web folder, for example. That HTML file will go out to the browser and then be rendered in the browser, showing all the elements of markup that are on the page. So, for example, you're going to have the hyperlinks for navigation, you've got buttons to submit various forms, you've got images, you've got text, whatever you've got. So that's inside that index.html file. And as part of that index.html file, you might have, for example, JSP tags in there, which are rendered on the server. So in other words, they're converted from their JSP format, which is a Java technology, Java server pages. They're going to be transformed into the actual HTML elements that the end user is going to see. So for example, maybe you have a JSP tag to get the username from the session, for example. So on the server, you have the JSP, which is using that tag, and then the application server or web container, whatever you want to call it, like Tomcat, that'll basically interpret that, convert that into HTML by getting the actual value of the username out of the session, and then it will then send the HTML back in a HTTP response back to the client, so back to the browser that made the request initially. In that example, it wouldn't be index.html, it'd be index.jsp, and it probably wouldn't be called index either, it'd be called something else, but you get the idea. Basically, in a web application, in a Java web application, you have a set of web pages which use a technology like JSP. You're going to have a set of servlets or a set of controllers if you're using a framework like Spring, for example, using Spring's MVC technology. And inside those controllers, you're going to have logic to get the model that's passed in, assemble it back, choose a view, and then ship it back out to the user. Or if you're just using servlets, you're going to implement the method which is serving the GET request or whatever it might be, which has the sort of HTTP servlet request and HTTP servlet response objects, using those as you see fit to be able to look at what's in the request, do the bit of business logic you need to do, and then assemble the response, which is going to be shipped back out to the user, that kind of thing. Those are Java web applications. So that's what you have really with a Java web developer role. And so in that kind of role, and with those kind of applications, and those apps, by the way, are just deployed as a single WAR file in a web container. You might have a few web containers which are arranged together in a so-called cluster. So for example, 3 separate instances of Tomcat, which have the exact same web application, the exact same WAR file deployed on them. And if you have that kind of arrangement, then because you have more computers, because you have more nodes, you can then serve more clients at the same time. And typically you'll have a thing called a load balancer, which sits in front of that, where a request comes in to the load balancer, and then the load balancer chooses which instance of the web container it's going to route the request to, and that's how it so-called balances the load, hence the term load balancer, out across the nodes in that cluster. That's all kind of like advanced architectural stuff, but just know the fact that for this Java developer type, just for a Java web developer role, the technologies you're using are things like JSPs, servlets, JSTL, which is the Java standard tag library. You're also going to have, again on the web side, an understanding of HTML, CSS, cascading style sheets for being able to style the markup that you send back, and probably a reasonable knowledge of JavaScript to a certain extent. That's a scripting language that actually executes on the browser itself. And more recently, it's useful to know about component frameworks which build on top of JavaScript, which kind of enable you to do sort of like OO on the client side. So that's when the code's actually running inside the user's browser, using one of 2 frameworks these days, which is either Angular or React. And it's not so much doing OO on the client. Angular and React are more component frameworks for JavaScript. So they're frameworks basically which enable you to create self-contained components which are easy to code, test and manage in the kind of JavaScript world. But of course, in general, most of our skill set is going to be on the Java side. So if you're just doing a Java web developer role, you're going to be looking at JSP, servlets, JSTL, and alongside that, HTML, a little bit of CSS, minimal amount of JavaScript. You probably won't get involved with Angular or React. And your bread and butter is basically going to be knowing about Java servlets and Spring MVC, and being able to use Spring MVC's annotations, or even another back-end web framework in Java, like for example struts, if you're doing an application which is pretty ancient. And there's other templating languages as well which are useful to know about, such as Velocity, FreeMarker, and Timeleaf as well. But nowadays though, the chances are that the web app's actually a Spring Boot application, which makes things a lot easier to code for. And you're just basically coding them by convention over configuration. So you're just basically plugging in controllers which handle the web requests by annotating them with special annotations which Spring Boot gives you, which it gets from Spring MVC, creating services which you inject in to controllers, which are again annotated with another annotation. So you've got @controller to create controllers, you've got @service to create services, and in turn those services will access repositories which are built on Spring Data, JPA or whatever, and they'll be annotated with @repository. And in that way you have a layered application where you basically have the web layer consisting of controllers. Underneath there you have the service layer consisting of services, and underneath that layer you have the data layer consisting of repositories. So that's kind of like a Java web developer kind of application. Now springing out from that, we've actually got variations on that. So if you're a full stack developer, a full stack Java developer that is, then you're going to need to know all of that stuff we've just spoken about, and in addition either Angular or React. And you're going to have a relatively good knowledge of how the front-end stuff kind of hangs together, and even front-end build technologies too. So for example, Grunt and Bower, Webpack, those kind of things. So just like we have Maven in our Java world, or Gradle, which are dependency-based build systems, where you have dependencies which live in a massive repository, and you can pull them down by name and pull down these graphs of dependencies, or chains of dependencies if you like. Similarly, in the JavaScript world, they also have Grunt or Gulp, which are older build systems, which are the same kind of thing as Maven pretty much. And then Bower, which is a dependency system, where instead of accessing the Maven central repository to get components, you're accessing the npmjs.org repository to download JavaScript components. And there's more modern stuff now too, with like things like Webpack and everything. But yeah, as a full stack Java developer, you'll be expected to know all of that kind of stuff. Now, just like with a core Java developer role, which is very lucrative and you get a lot of money for, and the reason for that is because it's very complex, similarly, you can also get a lot of money for full-stack Java developer roles, and the reason for that is not so much that they're complex in terms of the depth of knowledge you need to have, it's more complex in terms of the breadth of knowledge. So whereas core Java is you just need to know Java at a really, really deep level, and it's just core Java you need to know. Contrast that with a full-stack Java developer. What they're paying you for there is the breadth of knowledge that you're knowing. So it's not just Java. You're knowing, back-end technologies which hang off of Java, front-end technologies which hang off of JavaScript, and everything in between, and also the architectural stuff as well. So knowledge of how HTTP works, also possibly to a lesser extent how the security works, and knowing how to work with different tool sets as well, like Chrome developer tools, that kind of stuff. So for that kind of role, you've got to be a good all-round technologist who's interested in web technology first and foremost, and has a kind of a natural curiosity to be interested in that web kind of tech area. Whereas for a core Java developer, you need to be interested in really drilling down deeper and deeper with your Java knowledge and really understanding the nuts and bolts at the most basic foundational level of how to make really performant systems. So we've covered core Java developer, Java web developer, a Java full stack developer. So the other aspect as well, if you take a Java web developer role, which we've described, and you remove any of the HTML and JavaScript type stuff, and obviously we're removing things like Angular and React because that's too front end, and you orient the type of work you're doing to REST-based APIs. So REST is a style of interaction with web APIs, which is popular in microservices-based architectures, which I'll describe in a second. But if you take that, so just looking at things like Java with Spring, Spring MVC, and JAX RS, or Jersey, and knowledge of how to develop REST APIs and work in a microservices architecture, then that gives you the other role, which is a Java backend REST developer, I'd call it. So in a microservices architecture, what that's really about is instead of having one application which all lives in the same WAR file, you basically split up your application into different components, which are called microservices, and those components are deployed. So these microservice components are deployed separately in their own web container. So either they're deployed as a WAR file in Tomcat or WebSphere or WebLogic or one of the other application servers, JBoss, whatever. Or more commonly, they run standalone as a Spring Boot application, where Spring Boot has a version of Tomcat which is embedded in it, so it can actually act as its own web container. In a microservices environment and architecture, you've got many different microservice components which are all running at the same time, and each microservice component exposes a REST API, so in other words, a specific URL pattern, which is kind of like a specific set of URL patterns which you can call from other clients. Again, over HTTP, so it's still request and response, but typically in this environment, your requests and responses in general are made up of JSON. So JSON is the JavaScript object notation, and that's basically the main way in which web applications these days communicate non-trivial chunks of information. So REST-based APIs, they're the new way of getting data into and out of an enterprise application, and REST stands for Representational State Transfer. And it's basically just a nice standardized way of being able to access and to store and update information in different systems. So what we do pretty much with REST is you have URLs which expose certain objects of your domain. So if you imagine you're working on, say, a library system. So you write a REST API for a library system, and a library in terms of physical library where you can borrow books and return them and that kind of stuff. Then under a REST API way of doing things, you maybe have a URL which ends with /books. So if you make a GET request to /books, obviously there'll be the server name beforehand, so http:// myfantasticlibrary.com/books. When you make that GET request, it'll return you basically a JSON structure which has all of the books in the catalog arranged as a kind of an array or on a list, if you like. If you just wanted to get a specific book, you wouldn't just do /books. You could do /books/ and then maybe the ISBN number or the natural key for that book. So let's assume ISBN numbers are just like the numbers 1, 2, 3, 4, 5, which are not, but just imagine that. Then to get a book with ISBN number 3, you could do /books/3, make a GET request of that, and you just get back that single book as a JSON structure. If you then wanted to update an element of that book, you can then do a HTTP put request, and the URL then would be /books/3 because you're updating book with the ISBN number 3. And also as well, if you wanted to create a book, then you do a post request, so HTTP post request to the books collection, so HTTP post request to /books, passing in the JSON of the book, which represents the data points you want to have created for that book, and in doing that, then it will create the book on the back end as well. So pretty much what REST enables you to do, I mean, it's not as straightforward as that, but in a nutshell, what it enables you to do is effectively do CRUD operations. So CRUD's an acronym from databases, but you have create, read, update, and delete. So CRUD operations against domain objects, which are exposed by your REST API using the different HTTP methods. So using things like get, post, put, delete, that kind of stuff. So as a Java backend REST API developer or microservices developer, what you're going to know about in that context are, again, things like Spring MVC, things like JSON, knowing how to use Postman, which is a tool from Google Chrome, I think it is, which enables you to do these different requests and to also understand how REST works, at least at a basic level. And that, in my opinion, is pretty much it for the main Java developer roles. So to summarize, you've got a core Java developer role, which is just working with core Java. So no third-party libraries, just pure Java as low as it gets. That's used in banking and high-performance trading systems. You've got a Java full-stack developer, where you need to know back-end and front-end technologies. So you need to know Java, Spring MVC, all that kind of stuff. And also on the JavaScript side, JavaScript itself, a component framework like Angular and React, and associated front-end technologies too, like HTML and CSS. Bootstrap for responsive design, that kind of stuff, as well as knowing how their build tools work on that side of things, and knowing how the web works in general in terms of request response. Also knowing about Ajax, which is where you just update certain parts of the web page without having to do a full request response, which I didn't touch upon before, but that's something else you need to know. If you remove a lot of the front-end stuff, so definitely remove Angular and React, knowledge of the front-end build tools, that kind of stuff, and focus more on Spring MVC, and server-side web technologies in Java like JSP, servlets, JST, all that kind of stuff, then you've got a Java web developer role. And again, if you remove the front-end stuff from that, so remove JavaScript, HTML, CSS, that kind of stuff, and instead replace it with REST, JSON, Postman, and a knowledge of microservices, then you end up with a Java backend microservices REST API developer. So yeah, those are the four main different Java developer roles that you can have. And in order to become fully fledged as a Java developer, what that question really equates to is, first of all, working out which one of those roles resonates the most with you, which you'd most like to do. And from that point, just basically developing the skills and the skill sets that you need to be able to work in that Java developer role. So I hope that was useful. Thanks for staying with me. It's a lot of complex stuff, but what I want to do is basically throw as much stuff as possible into an episode so you can at least be exposed to different terms, different technologies, and then you can obviously go away and have a look up and a read up on different things as certain things pique your interest, that kind of thing. Hope you got a lot of value from it. And that about wraps it up for this episode. Also, if you haven't checked out the Java Easily Facebook group, where you can ask questions and join a friendly, supportive community of beginner and intermediate Java developers, then head on over there and send out a join request. Also, if you're completely new to Java, which is probably unlikely if you've managed to make it to the end of this episode, but if you're completely new to Java, then you can check out the Beginner's Java course, which is over at courses.javaeasily.com. And again, at that URL, courses.javaeasily.com, we've got all the other courses which we have to help you out in your Java travels. I'm going to put something on the website soon where you can actually post audio snippets. So you can record yourself asking a question by audio for the podcast, and I'll try and answer it in the podcast, or at least do an episode on it. So that's going to be fun. And in the meantime, have a great day, stay safe, thanks for staying with me, and we'll speak soon. Bye.